Hello guys, so I would like us to look at Laplace transform. Now, Laplace transform of a particular function is basically given by the integral from 0 to infinity of exponential negative st multiplied by that function dt. Now, Laplace transform is linear such that if you have two functions which have been joined together by addition or multiplication, getting the Laplace transform of the whole of this is just the same as getting the Laplace transform of each one of them separately. Now let's look at how to get the Laplace transform of some basic functions. So let's start off with a constant. Now, given a constant k, and then you're being told to get the Laplace transform. So how do we go about it? It will be the integral from 0 to infinity of exponential negative st k dt. So this is a constant. We can write it outside the integral sign so that we have integral from 0 to infinity of exponential negative st dt. And this gives k, integrating exponential negative st, we have exponential negative st over negative s, integral from 0 to infinity. Replacing the ranges after integration, what do we have here? So we have k replacing negative infinity where there's t. So I have negative s and then infinity, all this divided by negative s, minus k exponential negative s replacing 0 now, all this divided by negative s. So what is this going to give? So we have exponential k exponential s multiplied by infinity will just be infinity still, negative s minus will give us a plus. Then you have k exponential multiplied with 0 will have exponential minus 0, all this divided by minus s. Now, what is exponential raised to the power of infinity? Now, we all know infinity is a very big number. So what happens if you take, so we have exponential raised to the power of minus infinity. This is the same as 1 over exponential raised to the power of infinity. Now, infinity is a very big number. So this is the same as 1 over exponential raised to the power of infinity will just give you a very big number. Now, what happens when you take a small number like 1 and then you divide by a very big number? Your answer will be approaching 0. Like, just let's take 1 divided by 1, like 1 million or something like that, you'll be getting 0.00000. So obviously your answer will be 0 if you take 1 and then you're dividing by a very big number. So this here translates to just 0 plus, so minus gave us a plus there, so we don't have this minus over here. So plus exponential raised to power minus 0. Exponential raised to the power minus 0 is the same as 1 over exponential raised to power 0. 1 over any number raised to power 0 is 1. So obviously this is just going to translate to 1. So here we have k over s. So k over s is our Laplace transform of a constant k. Let's take up another example. Let's say you're getting the Laplace transform of t. So your f of t is equal to t. So the procedures, they're just the same. We'll just be integrating. So our f of t is equal to t. So the Laplace transform of t will obviously be given by integral from 0 to infinity of exponential negative st of t dt. Now we are going to use integration by parts since we have two functions which have been joined together by multiplication, and we need to write this in order, like following the order: logs first, inverse trigonometric, algebraic, then trigonometrical functions, exponential. So here we have an algebraic function and an exponential function, and clearly algebraic function appears before exponential. So this will be written as integral from 0 to infinity of t exponential minus st dt. So using integration by parts, we are going to let the t be equal to u, and then this one be equal to dv. And the formula for integrating by parts is uv minus integral of v du. So carrying out the integral, if u is equal to t, so u is equal to t, what is du dt? Du dt is equal to 1, hence du is dt. Now dv dv is equal to exponential negative st. So what is v? To get v, we integrate this, so it will be exponential negative st over negative s. So we come and fill this into the integration by parts formula. So we have uv, so uv, our u is t, multiplied by v, which is exponential minus st over minus s, minus integral. So we've already finished this. We can put the range is from 0 to infinity. Integral from 0 to infinity of v du. And what is our v? V is exponential negative st over negative s multiplied by du. And our du, as you can see here, is dt. So what does this give? So we are going to integrate and then simplify. So on this side, if we integrate this side, we will have, so minus minus will give us a plus out here. And then here I can take out 1 over s since it's a constant, and then remain with integral from 0 to infinity of exponential negative st dt. So this side will just remain the way it is before we actually insert the ranges from 0 to infinity. Okay, fine. So what does this give? So I want to insert the ranges. Now, inserting the first time infinity. So what are we going to have? Now, if we put infinity here, we will have infinity, then exponential minus s, infinity over minus s, minus, inserting 0, we will have 0, then exponential minus s of 0 over minus s. So that's for the first part there, plus 1 over s, integrating exponential minus st, will have exponential minus st over minus s, and the range is from 0 to infinity. Okay, let's deal with the first part and replace the value. So exponential minus s infinity will give us exponential minus infinity, which I already explained is the same as 1 over exponential infinity, which is 1 over infinity, and this will give 0. So if this is 0, it does not matter what this is. This will obviously just translate to 0, minus this is also 0, so that will give 0. So plus, so we have plus over here, and we have minus over here. So let's see, this is minus. Okay, fine. So let's replace the ranges over here. So I have 1 over minus s squared exponential minus st integral from 0 to infinity. Okay, fine. Replacing infinity, what do we have? So replacing infinity, we will have 1 over s minus s squared, then exponential minus s, then infinity, minus replacing 0, I'll have 1 over s squared, so minus, and then exponential minus s0. So what does this translate to? So this will be given by, because of exponential minus infinity, we will obviously have 0 here. And then we have minus minus, this will give us plus. Exponential raised to power 0 is 1. So our answer is 1 over s squared, basically. So clearly, if you evaluate the Laplace transform of t, you will get 1 over s squared. Okay, in a similar manner, I would want us to do Laplace transform of t squared. So Laplace transform of t squared. Now just go straight ahead and write integral from 0 to infinity of t squared exponential negative st dt. Because we already know that the format is algebraic comes before exponential, so we write it like that. Now let this be your u and let this be your dv. We're going to just repeat the same process. So if then we are looking for uv minus integral of v du. Now if u is equal to t squared, what is du dt? So du dt will obviously be 2t. So meaning du will be equal to 2t dt. Okay, fine. Now dv is equal to, so dv is equal to exponential minus st. So what is v? We get v by integrating this, so that will be exponential minus st over minus s. So that will obviously give us that. So now let's replace those values into the formula. So we'll have uv. So what is our u? Our u is equal to t squared multiplied by our v, which is exponential minus st over minus s. Okay, integral is from 0 to infinity, minus integral from 0 to infinity of v. What is our v? Our v is exponential minus st over minus s multiplied by du, and our du is 2t dt. Okay, fine, guys. So going ahead to replace the ranges here. So where there's t, I'll put infinity, infinity. Because of exponential minus infinity, that will give us 0. Minus, putting 0 here. Because of this will give us 0, the t there. So I have minus, that will be plus. Remove the constants outside. So I have 2 over s. Then what do I have inside the integral sign? Integral from 0 to infinity of t, because we have t and exponential, so I'll start with t exponential minus st dt. Now we already evaluated this one in the first part because that's what we were looking for. We evaluated the integral here, Laplace transform of t. We evaluated this integral and we got that the answer was 1 over s squared. So I really don't have to do it again. I just want to replace it here. So I have this as 2 over s. If we check our working previously, we got that as 1 over s squared. So this basically gives 2 over s cubed. Very fast, let's look at if you're told to get the Laplace transform of t cubed. So the procedure is going to be the same. This is going to be the integral from 0 to infinity of t cubed exponential negative st dt. Let this one be u, let this one be dv. Okay, so if this is u dv, we are looking for uv minus integral of v du. Now let's identify our values. U is t cubed. So what is du dt? Du dt is 3t squared, meaning du is equal to 3t squared dt. Okay, fine. And our value for dv, so our dv right here is equal to exponential minus st. So our v is exponential minus st over minus s. Replacing those values into the formula, we have uv, which is t cubed, multiplied by v, which is exponential minus st over minus s. Integral is from 0 to infinity, minus integral from 0 to infinity of v. What is our v? Exponential minus st over minus s, multiplied by du. So making du the subject of the formula here, we will have 3t squared dt. Okay, fine. So I want to replace the values in this first one, replacing infinity here and here. Because of exponential minus infinity, we will get a 0, minus replacing 0 here and here. Because of this t here, we will get a 0. So 0. So minus, that will give us a plus. Take all the constants outside. So I have 3 over s, and then I remain with integral from 0 to infinity of t squared exponential minus st dt. Guys, this is what we looked for in example number 2. We were looking for the Laplace transform of t squared, which is obviously given by this, and we got it to be equal to 2 over s cubed. So basically, I'll just come here and write, so this side is 0, 3 over s. We got that the Laplace transform of this was 2 over s cubed, and this will give us 6 over s raised to power 4. Now I want to write all the answers side by side so that we see that there's a particular recursion formula. So Laplace transform of t, we got it to be 1 over s. Laplace transform of t squared, we got this to be equal to 1 over, 2 over s was it 2 or 1 over s squared? So Laplace transform of t was 1 over s squared. And then Laplace transform of t cubed is equal to 1 over 6 over s raised to power 4. Okay, wait a minute. I've already replaced this correctly. So Laplace transform of t squared is, I've not written the one for t squared. I have. So the one for t squared is actually 2. Is it? So let's just go back and check what we got. So the Laplace transform of t, let's start with that. We got the Laplace transform of t as 1 over s squared. And then the Laplace transform of t squared was 2 over s cubed. So yeah, let's correct that. So 1 over s squared. So the Laplace transform of t we got as 1 over s squared, then this was 2 over s cubed. Now, what will be the Laplace transform of tn? As you can see, there's some repetitive formula there. So the Laplace transform of tn is given by n factorial over sn plus 1. Clearly, you can see if we were to use this general formula to rewrite this, the Laplace transform of 3, let our 3 be n, then it will be 3 factorial over s 3 plus 1, and this basically 3 factorial is 6. This gives us this. If we were to use it to get this one, n factorial, so our n here is 2, so we will have 2 factorial over s 2 plus 1, and that also gives us the answer. And finally, if we are having our n as 1, so 1 factorial over s 1 plus 1, so that will obviously give us that. So basically, the Laplace transform of t raised to power n is that. Okay, very fast. Let's look at how to get the Laplace transform. So number 4, our ft is equal to exponential at. How do we get the Laplace transform of that? Okay, fine. So for that, we have integral from 0 to infinity of exponential negative, so exponential negative st exponential at dt. Since they're both written in terms of exponential, so I'm going to put them together. Now, this is how I put them together. I will have the negative outside, so t is common in both instances, and then since I have negative t outside, putting these powers, okay, let's do it like this at first. Let's put them under the same powers, so we'll have negative st plus at this dt. This is the same as us having integral from 0 to infinity of exponential. I'm taking out negative t, and then I will remain with s positive minus a dt. So this is what I basically integrate and replace the ranges. Now, integrating the exponential function there, we will have exponential negative s minus a t over negative s minus a, and then we are integrating from 0 to infinity, replacing the ranges. So replacing infinity here, we will obviously have exponential minus infinity over minus s minus a minus exponential, replacing 0, so we'll have minus 0 there over minus s minus a. So what does this translate it to? Because of exponential minus infinity, we will obviously have this as 0. Minus minus will give me a plus. Exponential raised to power minus 0 is 1. So I will have 1 over s minus a. And this is basically the Laplace transform of exponential at. Finally, how do we get the Laplace transform of exponential minus at? So the procedure is the same. We integrate from 0 to infinity of exponential minus at exponential minus st dt. Put them under the same base. So both exponential, you'll have exponential minus at minus st dt. This is the same as in from 0. So notice all the time I'm taking the minus outside. So I'll take minus t outside, then I will remain with s plus a dt. Integrating that, I'm going to have, so the integral of that will be exponential minus s minus a t, all this divided by minus s minus a. and the integral is from 0 to infinity. Replacing the ranges, replace infinity the first time where there's t, so the whole of that will just be exponential minus infinity over minus s minus a, and then wait a minute, s plus a, minus, replacing 0 because of this, so we'll just have exponential minus 0 over minus s plus a. So exponential minus infinity is 0, we'll have 0 there, minus will give me a plus, so exponential minus 0 is 1, so I'll have 1 over s plus a. And this is basically the Laplace transform of exponential minus a t.